Hello, Chemistry 10HH students. This is Mrs. Altman. We are on video number 1, Chemical Foundations, part 1. So at the time in which I'm recording this video, I am not sure if we will be in person when I actually introduce this video to you. So I'm going to just take a moment and tell you what my expectations are when I assign a video. When I assign a video, there's going to be typically slides with notes on them. I just check that you have taken notes. You don't typically have to draw the pictures. If there are pictures in my notes, I will tell you when you need to do that. But I just do a note check. All I check is that you have taken notes, and then you get a completeness grade for having taken them. You don't need to write down the objectives when I give you the videos. I really keep these here just so that you have an idea of what the expectations are with each video. And then I combine all the objectives together when we make study guides for tests such that you know what is expected of you. But don't feel like you have to write them down unless it is your personal preference. I do put a suggested reading in here. I don't think it is necessary to do the reading for each and every video, nor do I expect that because that would be very time consuming. But if you have a particular video that you are really struggling with, you can go to the objectives, find the suggested reading, and then use those book pages to help you understand that topic. But I don't expect for you to do that each and every time, again, unless that is your preference and that works very well for you. Pause here and take a moment to take some notes. Before we can really move on to the rest of the chapter, which will primarily focus on lab skills, we're just going to take a moment to define what this course is about. Chemistry is the study of matter and changes in matter, matter being anything with mass and volume. And then we'll talk about different types of changes. We're going to primarily talk about chemical and physical changes. There are other types of changes, but those wouldn't really fall under the category of chemistry. And then to study chemistry, we need to observe the world around us. So there are quantitative observations. So that's anything that includes a unit and a measurement. So 12 inches, 5.552 seconds, 250 milliliters. So you need to have both components. And then there are qualitative observations. These describe things that are non-quantifiable. So like the fact that you could be in a lab and you see something change from green to blue. While it is actually theoretically possible to measure wavelengths, if you're just observing it with your eye, you would just write that in your notebook that it changed from green to blue, and that is a qualitative observation, both of which are valid. Quantitative observations do tend to be more reproducible. Pause here. So within this course, we will be talking about different types of theories and different types of laws. And I expect that you've seen this before in biology as well. So I just wanted to do a quick recap of those theories. These are explanations of behavior. You cannot prove them true because they are ideas. So for example, the theory of gravity is that things pretty much fall to the earth because of an intrinsic force. And so while you can show that things fall to the ground, that does not prove that there is an intrinsic force. So theories have no information to prove them false, but you can't prove them true because they are ideas, whereas laws just summarize behavior. So the law of conservation of mass just states mass is never created or destroyed in a chemical reaction. It does not explain the reason why. Ideal gas law, pressure times volume is equal to number of moles times a constant times temperature. That is just shown to be true. It does not have any explanation. There is actually something called kinetic molecular theory that helps to explain why, but that is a theory as opposed to the ideal gas law that just states what they are. And then we also have hypotheses. So these are educated guesses or predictions that have not been tested and haven't been tested enough. So hypotheses can sometimes turn into theories, but they have to be tested a lot. Pause here. You do not need to draw the picture. All right, now we're going to get into what I think is really the important part of this video because it's something that we're going to be using for the rest of the year. So whenever you're using a measuring tool, so I'm specifically going to be talking mostly about volume, so graduated cylinders, beakers, etc. You, the observer, must estimate one digit or 10% more than the smallest increment of the tool. So if you take a look to the image that I have, even though it's only labeled every 10, there's lines in between it. So those lines are every 1 milliliter. So you absolutely must estimate to the nearest zero point 0.1 milliliters. So I would say that that is 25.2 milliliters. You might say that it's 25.3, and that would also be correct. You could say that it is 25.1, and that would also be correct. If you think something is exactly on the zero, let's just say pretend that that line was right on the 25, you would say 25.0. Pause here. Right, so I'll just briefly walk through it. So for both of these, the line is pretty much right on the zero. You always go to what's called the bottom of the meniscus, so just the bottom of the line. So for the first one, I would say that that is 12.0. You could have said 11.9 or 12.1, but you absolutely must include that zero. And then for the second one, we have lines every 10, which means we must estimate to the nearest one. So I would say that that is 70 milliliters. I'll actually write that down so that you can see what that means. So the first one is fairly straightforward, 12.0 milliliters. The second one, if I didn't put that dot there, you might not know that I had thought it was exactly 70 milliliters, so I have to put that dot there. We'll talk more about that in our next video. Anyway, thank you so much for watching and have a wonderful night.